डाउन हो गई बैटरी।
चलो देख लो आप। मुझे याद भी नहीं लास्ट टाइम मैंने पढ़ाया क्या था। A very good afternoon to all of you guys. Last time we discussed about some basic terminologies, the mole balance over chemical reaction, terminologies like order of reaction, molecularity, elementary and non-elementary reaction, etc. And we also discussed how to write the rate equation for any chemical reaction. Okay, so today we will talk about that rate equation. So suppose if I say this is some chemical reaction taking place in a reactor, and I want to design that chemical reactor. So first thing first, I should know the kinetics of the reaction, and in kinetics the most important term is rate equation. So as per our knowledge, we can write the rate equation for this chemical reaction, and that will be K Ca power alpha Cb power beta, where alpha beta are the apparent orders of the components. So now, when I will talk about the designing of a chemical reactor, so obviously I will use the rate equation there, and in this rate equation I should know the value of K, that is rate constant, and the value of alpha and beta. So we will discuss about the methods to calculate the order of reaction, but before that we will talk about the methods to calculate the rate constant K. So next you can say the calculation of rate constant. Order of the reaction can be reduced if any component is in excess. Okay. Yeah, I remember I told you to find out this. Okay, we will discuss all that thing. Calculation of rate constant K. So first let's talk about the rate constant K. So rate constant K, also known as specific reaction rate. It is temperature dependent term only. Okay, rate constant K depends only on temperature. Why? That we will discuss in solution thermodynamics. Okay. And next, if I talk about the units of K, units of rate constant. So units of K are basically units of concentration power 1 minus n into units of time inverse. That's how you can represent the units of rate constant K. As we know that from the rate equation, from the power law, for any chemical reaction we can write R as K Ca power n, where n is the overall order of reaction. So let's say if we talk about in SI system, we use the units in SI system. So for rate for rate of reaction, for homogeneous reaction system, unit is mole per meter cube per second. For concentration, the units can be represented as mole per meter cube power n. So from there you can see that the units of K will be mole per meter cube power 1 minus n into second inverse. That is the units of K. If concentration and rates or time are given in any other units like kilomole per meter cube, kilomole per cubic centimeter, mole per liter, and time is in minutes, hours, seconds, anything, or days even, then we can find out the units of K in the respective terms. And similarly, we can also say that if we know the value of K for any chemical reaction, if we know the value of rate constant K for any chemical reaction, then we can find out the overall order of the reaction. Okay. For example, for any chemical reaction, let's say the rate constant K is given as 9 cubic centimeter power 9 over mole cube per minute. For any chemical reaction, let's say this is the value of K, 9 centimeter power 9 per mole cube per minute. Then what will be the overall order of the reaction? So from the units, see we have centimeter power 9. So the units of the volume in terms of centimeter are centimeter cube. So I can write this centimeter power 9 as cubic centimeter power 3 over mole cube per minute. Further you can write it as cubic centimeter per mole power 3 into minute inverse, and this term you can also write as mole per cubic centimeter power minus 3 into minute inverse. So now this is the unit of concentration, power minus 3, units of time inverse. So when you compare this with the general expression, with this existing expression, then you will find that 1 minus n is equal to minus 3, so n will be equal to 4. That is the overall order of the reaction, 4. So if we know the units of rate constant K, if we know the value of rate constant K for any chemical reaction, then we can figure out the overall order of the reaction. We cannot find out the apparent order, but yes, we can find out the overall order of the reaction, means alpha plus beta plus gamma, or in simple words, summation of alpha I. What is overall order of the reaction? Summation of alpha I. All of us know that. Okay. As per the definition, the sum of apparent orders is the overall order of the reaction. So this is something about the rate constant K. Is it clear, guys? say something. आपको क्लियर है? Yes. Wonderful. So guys, if it is clear to all of you, then I have a question. Please answer. And if you don't know the answer, then at least simply say no. Or no idea, whatever you want to say. But respond please. Huh? So my question is, as we know that the units of rate constant K can be represented by this method, by this expression. Okay. So guys, tell me, for which order of reaction rate constant K will be dimensionless, means unitless. Sorry, dimensionless and unitless are two different things. The question is, for which order of reaction the rate constant K will be unitless? Simple. Tell me the answer, like 1, 2, 3, 0, infinite, -1, -2, whatever it is. 1 by 2, 3 by 2, 0.5, -0.5, whatever is the answer. For which order of reaction the rate constant K will be unitless? तुम भी आंसर कर सकते हो. No order. Never. It's true. In this expression, if you even put n equal to 1 for first order reaction, 1 minus 1 will 0, so this term will be vanished, but still the time inverse, units of time inverse will remain. So K will never be unitless. K will never be unitless. Remember this. Okay. It has been asked in the GATE exam as well. So, let's say I am using two statements. Okay, I will share two statements with you and tell me which one of them is correct. Okay, so it is confirmed that K will never be unitless. Okay, so now I am using two statements. Tell me which one is correct. Both of them are correct, only one, second correct, first correct, whatever, or none of them correct. It can be anything. Okay, first statement. First statement is all dimensionless parameters will be unitless as well. Second statement is all unitless parameters will be dimensionless as well. Okay. in general I am asking. Okay, these are the two statements, dimensionless terms, unitless terms, all these things we used frequently in chemical engineering. Sometimes we also talk about the normalization of the variables, where we make the variables unitless, dimensionless. Okay, so out of these two statements, which one is correct, or both of them are correct, or both of them are incorrect, or only one of them is incorrect? Tell me, which one is the correct statement? Ketan Gandhi, second is correct. Atisha, second correct. Ankita, second is correct. Priyanka, second is correct. So you think first is incorrect? तुम्हारा क्या कहना है? कितना समय लगा सोचने में? इसमें कोई रॉकेट इंजन थोड़ी डिजाइन करना है. So according to you guys, second statement is correct, but it means you are saying that first statement will be incorrect. Okay, so it means some dimensionless parameters will have units. Okay, if any parameter is dimensionless, then it may have units or may not be. That depends on the parameter. So can you give any example of such parameter which is dimensionless but not the unitless? Second is correct, but there are no unitless quantities. क्या बात कर रहे हो साकेब? There are so many parameters which are unitless. Radian, what is that? Because radian is a unit of angle, but it's dimensionless. Radian is a unit, it's not a parameter. I think we should start with the process calculation, not the CRE. You guys are so confused about the units and dimensions. I am talking about a parameter. Radian is a unit. Like if I talk about liter, liter is a unit of volume. Liter is not a parameter. It's not a dimension. Ca by Ca naught. What is that? Mole fraction. Nusselt number. That is a dimensionless number and unitless as well. Bro. A very simple example is molecular weight, solubility, etc. Molecular weight is a dimensionless parameter but not unitless. And what are the units of molecular weight? Either gram by gram mole or kg by kilomole or pound by pound mole. Solubility, you must have heard about this term in mass transfer or process calculation, material balance. During crystallization, we mainly use solubility. What is solubility? The amount of solute, the maximum amount of solute that can be dissolved per kg of or per unit amount of solvent. Okay, it is also a dimensionless parameter but not unitless. So remember guys, we have many parameters, many parameters which are dimensionless but not unitless, like molecular weight, solubility, etc. And similarly, If any parameter is unitless, then definitely that will be a dimensionless parameter, 100%. Okay. So second statement is correct. Sir, can relative density also considered? Relative density means specific gravity. Yeah, specific gravity is the dimensionless parameter, but it is not a unitless parameter. So this is something about the rate constant K, guys. Now we will talk about the calculation. How can we calculate the rate constant K for any given reaction? What will be the example of unitless parameter? There are so many things which are unitless, like as one of your friends said, Nusselt number means there are so many dimensionless numbers which are unitless. Mole fraction is a unitless parameter. So for the calculation of rate constant K, we can use n number of theories as mentioned in the book. Okay, but based on our syllabus and the validity of the theories, the most popular and most used theory is Arrhenius theory, also known as Arrhenius law. According to Arrhenius theory, the rate constant K is equal to, rate constant K is proportional to e to the power minus E by RT. And when you remove this proportionality sign, you can have a constant of proportionality, let's say K naught. So this is the Arrhenius theory. This is the relation between rate constant K and temperature according to Arrhenius theory, where this K naught is also known as pre-exponential factor, as it is coming before the exponential term. Second, it will be independent of temperature. And third point, all of us know that normally all mathematical functions are unitless, be it sine, cos, log, exponential, anything. So similarly, if we have this exponential term, this exponential function will be unitless as well. And if this is unitless, then it simply means the units of left hand side and right hand side in any equation, the units of left hand side and right hand side should be same. So the units of K naught will be same as that of for K, that of for rate constant K. ERT. So I hope all of you know what is R. R is basically known as universal gas constant. T is the absolute temperature. And absolute temperature means it is defined in terms of Kelvin, as Kelvin is the one temperature scale which starts from the zero, and since it starts from the zero, so 0 can be 0 is considered 0 Kelvin is considered as the reference point, datum point in thermodynamics, in everything, in heat transfers as well, and so that Kelvin scale is considered as the absolute scale, and this temperature is the absolute temperature. And E is called activation energy. So if I talk, let's say we are talking about the energy. So as we are talking about the energy, so normally in SI system, energy is represent in terms of joules. So the units of R in terms of joule, I hope all of you know that it is 8.314 joule per mole per Kelvin. Okay. So tell me, what should be the units for activation energy E? For activation energy E, what should be the units? Joule per mole. Wonderful. As this exponential function is unitless, means the units of E by RT is 1, that is unitless term. We don't know the units of E. The units of R given as joule per mole per Kelvin. For temperature it is Kelvin. So from here you can see the units of E will be joule per mole. Okay. Now what is Arrhenius theory? Arrhenius theory suggests that suppose we have any container or a reactor, we feed n number of reactants in the reactor under certain reaction conditions. So when those reactant molecules enter inside the reactor, if that is a fluid, means liquid or gas, then we know that for liquids and gases, the molecules, the atoms are not stationary. They are always in motion. Okay. And when molecules are in motion, so they will have a random movement. Like if I talk about a gaseous reaction, then in gases we know that Brownian motion is there. So atoms, molecules will move randomly in a zigzag manner or whatever it is. They will move randomly in this container. So when those molecules, those reactant molecules are moving randomly, then they will have the collisions with each other. And when the molecules have collision, so you know that after the collision, they will exchange the energy, they will exchange the momentum. So some molecules will gain the energy, some molecules will release the energy. Okay. So if after the collision molecules have energy greater than equal to their activation energy, if after the collision molecules have energy greater than equal to their activation energy, then that is called successful collision, or you can say effective collision. And if molecules does not have energy greater than equal to this, means they have energy less than the required activation energy. What is activation energy? That we will discuss. So after the collision, if molecules have energy less than the required activation energy, then that will be the unsuccessful collision, or you can say ineffective collision, as those molecules will not participate in the reaction. Okay. So now what is activation energy? That is a point. So as the name suggests, activation energy In layman terms, we can say energy required to activate something. What something is here? That something is chemical reaction. So in layman terms, we can say activation energy is the energy required to activate the reaction, means to start the reaction. Okay. So what is the meaning of activation energy? Just let's try to understand. I hope all of you know that in any exam, normally on a school level or college level, if the exam, the total marks are 100, then normally the passing marks are 30. So in that exam, which is of 100 marks, if you get 30 or above marks, you will be qualified, you will be passed, and if your marks are less than 30, then you will be failed. So this is the reference point, means 0 marks. Obviously, before the start of any exam, before the starting of that paper, your marks will be 0. If you keep your answer sheet blank, obviously definitely you will get 0 marks. So initially we will have 0 marks. It can be negative. To pass the exam, we need 30 marks minimum. Okay. So suppose in exam, any one of us, we are giving the exam, and after 3 hours or 2 hours, exam is over. After few months or weeks, we got the result, and we saw that I am getting 27 marks only. So my marks in that exam are 27. Can I say I am pass in that exam? No. If anyone has 27 marks out of 100 in that paper, obviously he is not pass. He will not qualify that exam. But we know that in schools, in college, they have a provision to give some grace marks, and here it will be 3. So your class teacher, your examiner will give you 3 marks. Okay, so after getting those 3 grace marks, those teachers are so kind, they will give us 3 grace marks. So after getting those 3 marks, my total score will become 30, and then I can say I am passing this exam, I am qualified. And I am qualified, it means the additional marks I required to qualify the paper, you can say, is like a activation marks. Similarly, in any chemical reaction, the additional energy required to achieve that threshold, that limit, is called activation energy. Now what is that threshold? So if I draw a Arrhenius plot, okay, Arrhenius plot is between enthalpy on the y-axis and reaction path on the x-axis. What is that reaction path? Basically that reaction path means extent of reaction, or you can say reaction coordinate. And what is that? That we will discuss in solution thermodynamics. So Arrhenius plot is, suppose we have the reactants, this is the reference point, these are the reactants. As reaction proceeds, this is the product state, this is the reactant state, and this is the transition state, TS. Transition state. So you can say that you can see that before the starting of the reaction, the energy of the reactant is this. To achieve the transition state, they required some additional energy, this, and this additional energy is called activation energy. And what is transition state? We know that. What is chemical reaction? Chemical reaction is a process where the old bonds of the reactant molecules break, the atoms get free, and then those free atoms forms the new bonds, means a new identity, means a product. So transition state is the state where all atoms are in free state, means no bond formation is there, all atoms are free. So what is activation energy? We can say that activation energy is the additional energy required, to achieve the transition state, or you can say it is the additional energy required to break the old bonds. Okay, or otherwise you can also say, see, this is the reactant. Initially this is the enthalpy of the reactant, this is the energy of the reactant. I hope all of you know that enthalpy means the total energy. Okay, so this is the total energy of the reactant initially. After the collision they will exchange the energy, some molecules will gain the energy. So after gaining the energy, after receiving the energy, let's say the enthalpy of the molecule is this, on this level. So again you can see that if energy of the molecule is here, that is greater than this required activation energy, so that molecule will definitely participate in the reaction. So what is the minimum energy of the molecules? What should be the minimum energy of the molecules to participate in the reaction? This is the minimum energy of the molecule. So this minimum energy required to achieve the transition state is called activation energy. So you can define activation energy like additional energy required to achieve the transition state, or minimum energy required to achieve the transition state. In other words, you can also write it as additional energy required to break the old bonds, or the minimum energy required to break the old bonds. So this is something about the activation energy. Okay. And it is very easy to understand. Okay. Like if I give you a very simple example in Hindi. All of us are normal people, mango people. So in simple words, we can say we are the rahagirs in Hindi, who are moving in this real world. तो आप सभी ने गौतम बुद्ध, महावीर जैन, एंड देयर आर सो मेनी people, great people, उन सब की स्टोरीज पढ़ी होंगी आई होप, कि लाइक महावीर जैन जो थे, गौतम बुद्ध जो थे, ये सब स्टार्टिंग में किंग थे अपने किंगडम के, बाद में ये लोग जंगलों में चले गए, तपस्या की, फिर इन्हें कुछ परम ज्ञान की प्राप्ति हुई, एंड आफ्टर दैट दे बिकम लाइक अ गॉड. सो इनिशियली रिएक्टेंट मीन्स R means rahagir. हमारा सबका एम क्या है? टू गेट द डिजायर्ड रिजल्ट, टू गेट द डिजायर्ड प्रोडक्ट, मीन्स टू गेट द डिजायर्ड परम ज्ञान, परम ज्ञान पी। तो आप राहगीर हो आर से, तपस्या करोगे तभी परम ज्ञान मिलेगा। और तपस्या करने के लिए क्या चाहिए? गौतम बुद्ध, महावीर, जैन, इन सब ने क्या किया था? तपस्या करने के लिए जंगलों में गए थे, पहाड़ों पे, सभी जगह से साधु महात्मा सब जाते हैं, ठीक है। क्यों? क्योंकि वहाँ पे काफ़ी ज़्यादा एकांत होता है। तो इन्होंने सबसे पहले अपने बॉन्ड्स, अपने रिलेशंस, उन सबको ब्रेक किया था। तो आप राहगीर हो, अपने बॉन्ड्स को, अपने बंधनों से मुक्त होना है, मुक्त होगे तभी आप तपस्या कर पाओगे, तपस्या कर लोगे तो परम ज्ञान मिल जाएगा। सो दैट इज आर्हेनियस थ्योरी। They are the reactants, and when those reactants get the minimum energy required to break their bonds, they achieve the transition state. And when those atoms are in transition state, when all those atoms are free, they have two choices. ठीक है, आज आप क्लास कर रहे हो, ऑब्वियसली आप अपने रूम पर हो, just visualize when the things were normal. We used to go to colleges every day, मतलब not every day, on regular days, obviously, working days. आप कॉलेज गए, ड्रेस पहन के गए, वापस आए, नेक्स्ट डे फिर कॉलेज जाना है, then you have two choices, either to wear the new dress or wear the old dress once again, जो last day पहनी थी. Similarly, the atoms which are in free state here, they have two choices. Either those atoms can form the new bonds or they can form the old bonds once again. So if we have the reactants, they achieve the minimum energy, that is the activation energy. So their bonds break, and after that they achieve the transition state where all atoms are in free form, and then those free atoms have two choices, either to form the old bonds once again and get back in their original state, means the reactant state, otherwise those free atoms can form the new bonds to move to the product state. Okay, so this is Arrhenius theory. And I hope it is clear to all of you. Now, as we know that in an exam, the total passing marks were 30 from the reference point. Additional 3 marks we got, means the grace marks we got, we was able to qualify the exam. Okay. Similarly, if the reactant molecules got the additional energy, they will achieve the transition state. But what about the total energy from the reference point? So if I talk about this total energy from the reference point, then the total energy by the molecules, the total energy required by the molecules to achieve the transition state is known as threshold energy. And mathematically, if you want to write, you can write it as threshold energy, that is the total energy required to achieve the transition state, or you can say the total energy required to break the old bonds is called threshold energy. That is equal to the activation energy plus the energy of the reactants. So this is the threshold energy. This is the relation between threshold energy and the activation energy. Sir, can the energy level reach above transition state? Yes, it can. Just try to visualize. If we talk about the boiling of water, all of us know that at 1 atmospheric pressure, 1 atm pressure, the boiling point temperature of water is 100 degrees Celsius. Okay. So this is the water. Right now, let's say the temperature is 25-30 degrees Celsius at 1 atm. If I want to boil this water, the minimum temperature rise should be, if this is 30 degrees Celsius, let's say, so the minimum temperature rise should be 70 degrees Celsius. So according to that, I can supply the energy. Okay, I will supply the heat, the energy of the heat of this water, the enthalpy of this water will increase, the temperature of this water will increase, it will reach 100 degrees Celsius and then it will start to boil. But what if I supply some additional energy, some extra energy than the requirement? Means to raise the temperature of this water from 30 degrees Celsius to 100 degrees Celsius, let's say the minimum energy required, the minimum amount of heat is required 100 joule. But if I supply 200 joule energy, what will happen? The temperature can be greater than 100 degrees Celsius as well. Okay. So similarly, here the temperature of the energy of the molecules can be greater than this, because after the collision they will gain the energy, and obviously molecule will not, when the molecules will have the collision, then it is not certain that how much energy will be exchanged between the molecules, among the molecules. Suppose the required activation energy is 100 joule in any case. So it may happen after the collision, molecules are gaining only 70 joule energy or 60 joule energy, or even they can also gain 110 or 120 joule energy. Okay. So it depends. That's why the energy level can be anything. But the minimum energy required is this. What is the minimum temperature rise for this water to boil? That is 70 degrees Celsius. Okay, so that is the thing. Is it clear, guys? I hope it is clear to all of you. So tell me one thing. We know that what is threshold energy, the total energy required to achieve the transition state. What is activation energy? The minimum energy, the additional energy required to achieve the transition state. And this is the reactants energy, which reactant molecules are already possess before entering into the system. So now I have a question. In which situation, in which scenario, in which circumstance the threshold energy and activation energy of the molecules, in which scenario, in which circumstance, in which situation the threshold energy and the activation energy of the molecules will be same? If it is possible, then say what? In which scenario? If it is not possible, then you can simply say no, we don't think it is possible. But again, you have to give the explanation why it is impossible. Saqib, you are saying it is not possible. So why it is not possible? Why do you think it is not possible? I am repeating my question. In which scenario the threshold energy and activation energy will be same? I am giving you 1 minute to think. आप कुछ बोलोगे? सोच रहे हो? When reactants will be at 0 Kelvin, when molecular energy can't be 0 Kelvin, huh? True. when the threshold point and the reactant point are same. So only 3 people are answering this. What about all other people? Hello. If you don't have any idea, or if you don't want to give me the answer, then you can simply say no at least. Please. Utkarsh Tripathi. When reactants are at 0 energy level, so any molecule energy can't be 0. So it means, I think you are saying it is not possible. So now my question was, when the threshold energy and activation energy will be same. तुमने कुछ सोचा? नहीं. Some of you said that when the reactant's energy will be 0 or the reactants will be at 0 Kelvin. So guys, just try to understand. According to kinetic theory of gases, at 0 Kelvin, according to kinetic theory of gases, the kinetic energy of the molecules is directly proportional to the square root or something of the temperature. Okay, so if at 0 Kelvin, T will be 0, absolute 0. Okay, so kinetic energy will be 0 as well. And if kinetic energy of the molecule is 0, that means molecules are not in motion. And when molecules are not in motion, they are stationary, then molecules are considered as dead. And if molecules are dead, then just think, try to put some logic in this statement. A dead molecule, does a dead molecule can participate in a reaction? Have you ever seen a dead person going to some office or college or anywhere else, or dead person moving or doing some work or anything? So as a human, when the dead human can't do anything, then how we are supposing that a dead molecule can do anything, a dead molecule can participate in the reaction? We human are so big things and molecules are such a small things, even I can't show that to you. So this reason is not the answer. This is absurd statement. So don't use this statement once again. Okay. Now the second statement. Some of you said that, few of you, when the threshold point and activation reactants point are same. Basically, when you shift this reference point on the reactant energy, on this reactant, when you shift this reference point on the reactant, then you can see the total energy required from the reference point or the activation energy required, both are same. Okay, so threshold energy and activation energy will be same only and only when this reference point, this datum point is at reactants level. Okay. It is possible, bro, because we can, reference state is our choice. We can choose any reference state. Okay guys, so this is something about the RNS plot. We have still we have so many points to discuss about this. Second thing, I hope all of you have heard about a term known as equilibrium. Okay. Equilibrium. What is equilibrium? And so we will not discuss that thing, because whenever there will be a chance, then we will discuss that thing in detail. For now, in layman terms, in a very simple language, we can understand that equilibrium is the state where rate of forward direction and rate of backward directions are same. Okay, in any process, if it is a reversible process, so rate of forward direction and rate of backward direction, when both of these rates are same, then we can say that is a equilibrium state. Like if I talk about vaporization and condensation, when rate of vaporization and rate of condensations are same, that is the equilibrium state, vapor liquid equilibrium, and so on. Okay. So this was a question in GATE exam, okay, maybe in late 90s, I think. According to Arrhenius theory, in any chemical reaction, we have three states: reactants, products, and transition state. So out of these three states, in which two states equilibrium is possible? First, option A, reactant and transition state. Option B, transition state and product. Option C, both, and option D, none of them. You can understand, okay? Huh? So simply we have only two options here: reactants, transition state, and transition state and product. Okay, so out of these two states, out of these two cases, in which option the equilibrium is possible to achieve? तुम्हारा रूटीन क्या होता है? तुम्हारा पूरे दिन का रूटीन क्या होता है क्लासेस के अलावा? 24 घंटे पढ़ते हो? तो वही तो पूछा हूँ, लगभग सुबह किस टाइम उठते हो? लगभग 8 बजे। और क्लास वही 10, साढ़े 10, 11 बजे से होती है, तो 2-2.5 घंटे तुम आराम या रेस्ट अपना रेडी होते हो ये सब। उस टाइम कोई पढ़ाई करते हो क्या? वो सब में टाइम निकल जाता है ना, नॉर्मल डेली जॉब्स। आफ्टर क्लासेस 4, 5, 6 बजे तुम फ्री हो जाते हो, अपने रूम पे जाते होगे। उसके बाद जैसे अब क्लास किया, तुम रूम पे जाओगे, फिर क्या करोगे? जाती पढ़ना शुरू कर दोगे? आधा 1 घंटा रेस्ट करोगे, उसके बाद 15-20 मिनट रेस्ट करते हो, फिर पढ़ाई करना स्टार्ट करते हो। तो लगभग 6 बजे से पढ़ना शुरू कर देते हो, ये मानता हूँ मैं। हाँ, तो 6 बजे से फिर किस समय तक पढ़ते हो? लगभग रात के 1 बजे तक, मतलब 7 घंटे। उसमें डिनर वगैरह का भी टाइम होगा, मतलब 5-6 घंटा पढ़ते हो, और फिर सो जाते होगे 1-2 बजे, फिर सुबह 8 बजे, यही सब। तो 5-6 घंटे पढ़ते क्या आप? जो क्लास में डिस्कस हुआ वो सब पढ़ते हो? अगर तुम इतना पढ़ रहे हो जेन्युइनली, अगर तुम 6-7 आवर्स स्टडी कर रहे हो अदर देन द क्लास, तो तुम्हें ऐसे आंसर, इतने छोटे छोटे सिंपल आंसर देने में प्रॉब्लम क्या होती है? तो इसमें सब्जेक्ट क्या है? यहाँ तो कुछ है ही नहीं। सब कुछ जो मैंने बताया मैं वही पूछ रहा हूँ, मैंने कुछ अलग से पूछा ही नहीं। अब फर्स्ट डे इन द क्लास आई टॉक अबाउट द मिक्सचर्स, फेजेस, ऑल दीज थिंग्स। ये सब तो 9th क्लास से पढ़ते हुए आ रहे हैं हम सब। आई होप 9 to 12 तुम्हारे पास साइंस ही होगी। केमिस्ट्री पढ़ी है ना 9 से 12 तक? अगर तुम 7 आवर्स अदर देन क्लास स्टडी कर रहे हो, उसके बाद तुम्हारा रेस्पॉन्स ये है, तो आई विल सजेस्ट यू वन थिंग, वो 7 आवर्स स्टडी मत करो, इससे अच्छा उन 7 आवर्स में तुम कोई गेम खेल लिया करो, मूवी देख लिया करो, टीवी देख लिया करो, कुछ तो माइंड फ्रेश रहेगा। बेवकूफ़ मत बनाओ खुद को। They are students. Parents think that their children are doing study for so many hours. But what is actually happening? When a student sitting for the study, if he opens the book, you can see the page number is, let's say, 103. If after 5-6 hours you come back and still you will see, parents see that students are sitting, students are doing study, they feel proud, oh wow, my kid, he is doing so much of hard work. But if actually they see, they will find that after 5-6 hours again he is on the same page 103 or maybe 104. तो सेम यहाँ होता है, तुम जो कर रहे हो वो यही है, बेवकूफ़ बना रहे हैं हम खुद को कि हम 5-6 घंटे पढ़े हैं। 5-6 घंटे पढ़ने के बाद भी तुम्हें वो चीज़ नहीं पता जो लास्ट क्लास में डिस्कस हुई थी। अगर पता है और तुम आंसर नहीं कर रहे तो फिर कोई उसका भी फायदा नहीं है। एज अ टीचर, इफ़ आई हैव सो मेनी नॉलेज, मुझे सब कुछ पता है, बट मैं क्लास में कुछ एक्सप्रेस ही ना करूं, तुम लोगों के डाउट्स का आंसर ना करूं, क्या बोलोगे तुम जाके? क्या बेवकूफ़ टीचर है कि पता नहीं किसे ला के खड़ा कर दिया। तुम मैनेजमेंट को कंप्लेन करोगे कि कोई दूसरा टीचर ला के दो। हंस रहे हो? मैंने किया है ये सब, समझ रहे हो, बता रहा हूँ। व्हेन आई वाज इन स्कूल मैंने किए ये सब चीज़ें। पूरा दिन एक बुक खोली सबके सामने, जैसे सब रिलेटिव्स, घर वाले, मम्मी पापा इधर उधर हुए, भाई बहन जो भी है, बुक बंद करी, मोबाइल में कुछ करने लग गया। जैसे ही दिखा वो कोई आ रहा है, वापस मोबाइल साइड में रखा, बुक खोली, उसी पेज पर है। उन्हें लग रहा है कि हाँ ये तो पढ़ रहा है, वाह। तो मैं पहचान जाता हूँ कौन पढ़ रहा है कौन नहीं पढ़ रहा है। मैं बस इतना कह रहा हूँ, 7 आवर्स स्टडी मत करो, कोई नहीं बोल रहा इतना। अगर नहीं कर, इफेक्टिवली नहीं कर पा रहे, कोई फ़ायदा नहीं है। अगर सिर्फ 10 मिनट भी इफेक्टिवली निकाल पा रहे हो ना, उतना इफेक्टिवली निकालो कि 10 मिनट जो तुमने पढ़ा एक्चुअली वो याद तो है अगले दिन। 7 घंटे मैंने पढ़ा पर मुझे अगले दिन कुछ याद ही नहीं मैंने किया क्या था, तो फ़ायदा क्या है ऐसी स्टडी का? तो 7 घंटे को 7 मिनट ही कर लो, कम से कम कुछ रिजल्ट तो आएगा। एनीवेज, व्हाट इज योर आंसर गाइस? क्या क्वेश्चन था? आउट ऑफ दीज 2 स्टेट्स, रिएक्टेंट, ट्रांजिशन स्टेट एंड ट्रांजिशन स्टेट प्रोडक्ट, इक्विलिब्रियम इज पॉसिबल इन विच केस? ओके, रिएक्टेंट एंड प्रोडक्ट, ये तो ऑप्शन ही नहीं था केतन। रिएक्टेंट एंड ट्रांजिशन स्टेट, रिएक्टेंट एंड ट्रांजिशन स्टेट, अच्छा तुमने करेक्ट करा है बाद में, ओके। सो गाइस, दैट्स करेक्ट। The equilibrium is possible only and only between reactant and transition state. Why? Because if you see, reactants molecules are moving from reactant state to transition state. When atoms are in transition state, they can form the new bonds to move to this state, product side, and they can form the old bonds once again to move to the reactant side. So here we can see 2-side process is possible. But when atoms move to the product state, then it is not possible for these molecules, product molecules, to again go back in this transition state. This is a one direction process only. Okay. So equilibrium may establish only and only between reactant and transition state. Now, according to Arrhenius theory, we know that K is equal to K naught e to the power minus E by RT. So guys, as we can see, K will change exponentially with the temperature. Okay, I hope all of you know that e to the power minus infinity is 0 and e to the power minus 0 means 1. So here, as temperature increases, if we increase the temperature, then you can see that the value of this ratio E by RT decreases. And if this ratio decreases, means e to the power 0, e to the power minus this function is decreasing. So this value e to the power, जो power term, that power term will decrease. And if that power term decreases, means e to the power RT tends to 0. So the value of this function is close to 1, means that is increasing. If the value of this exponential function is increasing, it means the rate constant K will increase. Similarly, if you decrease the temperature, then this ratio E by RT increases. And if this ratio increases, you can see e to the power minus infinity means 0. The value of this function tends to 0. So if this ratio is increasing, the value of this function will decrease, means rate constant K will decrease exponentially. It will increase and decrease exponentially. So guys, in next class we will discuss this. Okay, so this is your job for today. Find out the variation of K and T. It will increase exponentially like this, or it will increase exponentially like this. What will be the graph between K and T? Okay, this is your job for today. If you are not able to find this, then no problem. We will discuss that. Okay. Now, here, this is the Arrhenius theory, and all of us know that it is easy to study, to analyze a straight line curve than the exponential curve. So let's try to change this function into some straight line function. Okay, so if I take log on both sides, I have K is equal to K naught e to the power minus E by RT. Taking log, that is natural log, on both sides, you will get ln K is equal to ln of K naught into e to the power minus E by RT. And all of us know that ln of A into B can be written as ln A plus ln B. Ln base is, for natural log, base is E. This is also E, so you can also write it as minus E over RT. So this is ln K, that is equal to ln K naught minus E over RT. And if you see, this is a straight line equation like y is equal to mx plus c, where m is the slope, c is the intercept. So if you draw this curve between ln K versus 1 by t, 1 by t means x, ln K is y. So it will be a straight line with the slope minus E by R. Repeat the question. Which question? I am just asking, according to Arrhenius theory, we have this relation K with and temperature, between K and temperature. So tell me, what will be the nature of the curve? If I draw a curve between K versus T, what will be the nature of the curve? It will be like this or it will be like this? Okay. Anyways, so this is the graph between ln k versus 1 by t, that is a straight line curve, and the slope is minus e by r, and the intercept will be ln k naught. Okay. If in any interview someone asks what is the characteristic of the straight line, what will you say? We have so many type of curves, we have so many type of graphs, parabolas, exponential curves, logarithmic curves, straight line curves, cubic, so many things are there. So for a straight line curve, what is the main characteristic? How can you differentiate a straight line with the other curves? Based on the slope, and the main characteristic of a straight line curve is the slope remains constant. For any straight line curve, the slope will be constant. That is the main characteristic of a straight line curve. Okay. So again, this is a straight line, means slope will be constant, and slope is constant. What is slope? That is minus e by r. So just focus here. Now see, slope is constant, that is e by r, minus e by r, and we know that r is already a constant. It means they are considering in this expression that E will be constant as well. What is E? That is the activation energy. So if E is constant, only then the slope will remain constant and the curve will be a straight line curve. So this is a assumption you can say in Arrhenius theory, that activation energy is independent of temperature. That's why we are able to draw the straight line. If activation energy is changing with temperature, if activation energy changes with temperature, then the slope will also change, and if slope is changing, then we cannot get the straight line. Okay, so in any exam, so forget about the exam, if in any problem or in an experiment you have to find out the activation energy for the given reaction, for any chemical reaction which is happening inside a reactor, you have to find out the activation energy, or you have to find out the rate constant K. Then what you need to do, in that, this is a reactor. Okay, let's say I want to find out the activation energy, then what you need to do? So feed will and going, some product are supposed to leave. Suppose this is isothermal reactor operating at temperature T1. Okay, for the same feed, same product, means same reaction time and everything, draw a curve between T versus, draw a table between T versus K. For different values of temperatures, you will get the different values of rate constants. And when you have the different values of rate constant and temperature, then use these values to plot this curve between ln k versus 1 by t. And for definitely that curve will be a straight line, and the slope of that straight line will be equal to minus E by R. From there you can calculate the activation energy. Now the question is, how can we calculate the value of rate constant K? We can measure the temperature with the help of thermometer, that is not a big deal, but how can we calculate the value of rate constant K at different temperatures? That we will study, that we will discuss in kinetic equations in next class. how can we find out the values of rate constant K for any given reaction at any time at any temperature T. Okay. For that we need kinetic equations that we will discuss in the next class. So this is something about the Arrhenius theory. So this is the graphical way to calculate the activation energy for any given system. Okay. Similarly, if you want a mathematical expression to calculate E, then what we can do? It's very easy. See, we have this expression. Let's say this is equation 1. Okay. So at temperature T is equal to T1, as we know that rate constant is the function of temperature only. So rate constant K will be K1. So this equation will become ln K1 is equal to ln K0 minus E over R T1. Let's say that is equation A 2. Okay. Similarly, at temperature T is equal to T2, rate constant K will be K2. Then this expression from the equation, if you put these values, it will become ln K2 is equal to ln K0 minus E over R T2. Let's say equation 3. So now just subtract equation 2 from 3. You will get ln K2 minus ln K1, that is equal to ln K0 will get cancelled because that is independent of temperature. E by R 1 over T1 minus 1 over T2, or you can write it as ln A minus ln B as ln A by B. Okay. So at temperature T1 put the value of rate constant K1, at temperature T2 put the value of rate constant K2, you can calculate the activation energy. Similarly, if any chemical reaction, if activation energy is given, then at T1 you know the rate constant K1. So with the help of activation energy you can calculate the value of rate constant K2 at any other temperature T2. So this is the significance of Arrhenius theory, that with the help of Arrhenius theory we can calculate the rate constant K with the help of activation energy, or we can calculate the activation energy with the help of rate constant K. All of us know that when the slope of any curve is 0, that will be a horizontal line parallel to x-axis. If the if slope is 0, dy over dx 0. I got confused. Dx is 0. Okay. If slope is 0, that will be a horizontal line parallel to x-axis, and if slope is infinite, that will be a vertical line parallel to y-axis. Correct. Thank God. So if slope is infinite, then the curve will be a vertical line. So similarly here, if activation energy is high, for any chemical reaction, we have n number of chemical reactions. So for any chemical reaction where the activation energy is high, then you know that slope is, if you draw a curve between L and K versus 1 by T, the slope is minus E by R. If activation energy is high, then the slope will be high as, and if slope is high, then the curve will be more steep. It will tends towards the vertical. And what is the slope? We know that the slope is dy over dx. So here you can see that if activation, and for any chemical reaction, if the activation energy is high, then the curve will be like this. It will be more steep. Okay, and the slope, that is dy over dx, will be like this. It means for a very small change in temperature, the percentage change in rate constant K will be very high. And if rate constant K changes rapidly, then we say that is a temperature sensitive reaction. Okay, so I hope it is clear to all of you. For any chemical reaction, if activation energy is high, that will be a temperature sensitive reaction. Is it clear, guys? This is all about the activation energy and the Arrhenius theory part, which we want to discuss. Okay, wonderful. So remember, guys, in GATE exam or anywhere in any other competitive exam or in interviews as well, if you need to calculate the rate constant K with the help of activation energy, or you have to calculate the activation energy with the help of rate constants and temperature data, then by default we will use the Arrhenius theory. Okay, we have n number of theories. I will discuss two theories more, that is collision and transition state. But in exam, if nothing is mentioned, then by default we will use the Arrhenius theory. Next is collision theory. as these theories are not in the syllabus, so we will not go in much details of these theories, but we will have the basic idea, because there were 2-3 questions in past 20 years about these two. One is collision theory, one is transition state theory. So according to collision theory, rate constant K will be equal to K naught T to the power half e to the power minus E by RT. According to transition state theory, K will be equal to K naught into T into E to the power minus E by RT. This theory is based on kinetic theory of gases, and as all of us know that kinetic theory of gases is based on the number of collisions between the gaseous molecules. So that's why this theory fails for unimolecular reaction. I hope you can understand that for unimolecular reaction means only one molecule is participating in the reaction. So if only one molecule is participating, then that single molecule will not have the collision with any other molecule. So that's why it will fail. Kinetic theory of gas will not be applicable. While this transition state theory is based on स्टैटिस्टिकल. कल से तुम मेरी क्लास में मत आना, ठीक है? आओगे तो जगने के लिए आना, अदरवाइज सोने के लिए मत आना. समझ रहे हो? अभी जो तुमने किया दोबारा ऐसा हुआ मेरी क्लास में, मैं तुम्हें मेरी CRE की क्लास में आना बैन कर दूंगा. वैसे भी आजकल सब कुछ दुनिया में ट्रेंडिंग में चल रहा है, इंडिया में स्पेशली बायकॉट करने के मामले में, तो मैं भी बायकॉट कर दूंगा तुम्हारा फॉर CRE क्लास. Okay guys, this is collision theory and this is transition state theory, and if you want to write these theories in form of what? In form of ln K2 by K1. Remember these are the small k, okay? Small letters. Then collision theory will be, I am writing this directly, and as we did for the RNS theory, you can do for the collision and transition state theory similarly. Okay, if you are not able to find out this relation, then you can ask this on the over the call or over the WhatsApp, or otherwise you can see this derivation in your study material. This is for collision theory. For transition state theory, it will be ln K2 by K1 is equal to ln of T2 by T1 plus E by R 1 over T1 minus 1 over T2. So this is something about the collision theory and transition state theory. So I hope guys now this thing will help you to solve some of the questions which are in assignment 1. Assignment 1, what is K naught? Where is K naught? I think you were sleeping when I tried the expression for Arrhenius law. No problem. Here you can see at temperature T1 rate constant K will be K1. Similarly at temperature T2 rate constant will be K2. So subtract equation 1 from 2. You will get ln K2 minus ln K1. K naught is same because it is independent of temperature, it will get cancelled and you will get this. Similarly guys, you can find out for collision theory and transition state theory. Got it sir? Slip of fingers, lols, a big lols. स्लिप ऑफ टंग होता है, स्लिप ऑफ फिंगर्स मैंने पहली बार सुना है. तो बिकॉज ऑफ स्लिप ऑफ फिंगर्स यू वर आस्किंग दिस थिंग. माय गॉड. आई नो बिकॉज यू आर टाइपिंग, दैट्स व्हाई यू आर यूजिंग दिस स्टेटमेंट स्लिप ऑफ फिंगर्स. हाँ, फिंगर्स स्लिप हो गए इसलिए मैंने कुछ पूछ लिया. कमाल इंसान है यार. Sir, is there any drawback of transition state or collision theory? Yes. Every theory has certain drawbacks because all of the theories we know that are based on the real ideal situations, ideal systems. But when we talk about the real systems, obviously we have to neglect certain assumptions. Similarly here, if I talk about these three theories, so by default in exam or in any other numerical anywhere, you have to use the Arrhenius theory by default if nothing is mentioned. Okay, like if it is mentioned in the exam, in the problem, that use collision theory or use transition state theory, only then we will talk about these two. Otherwise everywhere we will use Arrhenius theory only. Now Arrhenius theory was the main theory, it was the original theory, the first theory to calculate the rate constant K. Okay, so it was applicable for all type of reactions, liquid phase, gaseous phase, everything. For the gaseous reactions, they modified the Arrhenius theory after using some frequency factors, some kinetic energy parameters of the kinetic theory of gases. They modified the Arrhenius theory to this form. And as you can see, this is based on the kinetic theory of gases. So collision theory will be applicable only for the gaseous reactions, and even only for those gaseous reactions which are bimolecular or trimolecular. Further, in the modern physics, I hope you know that in modern physics every theory, every principle, every law of the physics, thermodynamics, everything is again we are redefining with the help of statistical mathematics. Okay, if you do masters, you will study the statistical thermo, where you will learn how we can redefine the laws of thermodynamics and everything in a statistical manner, in a mathematical manner. Okay, so if you define the Arrhenius law statistically, you will get this result. Yes. So they say this is applicable and more accurate for the liquid phase reactions. Because for gases and liquids, I hope you understand that for gases we can consider them as an ideal gas. If we change the temperature and pressure on the suitable condition, the gases start to behave like an ideal gas. But for what about the liquids? Liquids can never behave like an ideal one. Okay, because as such there is no effect of temperature or pressure on the liquids. So that's why they say that transition state theory is more accurate for the liquid phase reactions. But we will use this one only, Arrhenius theory. I hope it is clear now, Saqib. This thing will help you to understand the difference between these three. Again, we don't need to go in these much of details about these one theories. The important was Arrhenius law, and that's why I discuss all the important and relevant points of the Arrhenius theory. Now, solve the questions from your assignment 1, and from the next class, I hope that is tomorrow. Okay. In the next class, we will start to discuss some of the GATE previous year questions as well. Okay. So for that, you can contact to Lalaji. He will help you to download the GATE previous year papers book, the PDF. Okay. I don't know about the books or the courier facilities. You will get all those study materials with by courier or post office, maybe some, I don't know when, but till then you can download the PDF. You can discuss with Lalaji about the access of that PDF, how you can access that. Okay, because we will discuss the GATE previous year questions from the next class. Okay, we will discuss the topic, and after that topic we will discuss the GATE previous year questions of that topic from last 20 years, so that you can get to know that CRE is such a easy subject. Okay, and you can easily secure 9 to 11 marks out of 10 to 12 in GATE exam. And if I talk about the book for chemical reaction engineering, as such you don't need to refer any book. My class notes and the class, that is more than sufficient for the CRE, at least for the GATE exam and for the MTech interviews. Okay. So right now our focus is GATE exam to get the rank, to get the marks. Okay. So focus on, you don't need to refer any book. Even you don't need to refer any book for the extra numericals, because I will give you the assignments, and all those assignments already have the important questions, important solved and unsolved examples of various textbooks. Okay, so you don't need to refer any textbook even for the numerical part. So that's all for the day, guys. We will stop this class today, and from tomorrow I want to ask you one thing. As you have your PDC class from 1 to 3, so will it be fine with all of you that if we start this class just after that, maybe from 3 or 3:15 p.m.? Because I think you don't need that 30 minutes gap in between PDC and CRE. So will it be fine with you if we start the CRE just after the PDC class, maybe 10 minutes after the PDC class at 3:15? 3:15 is okay. 15-minute gap should be there. Okay, guys. And for the schedule, if any one of you still have the problem to check the schedule, then follow the Facebook page of the GATE coach. The schedule is posted daily till at max 7 or 8 p.m. Okay. Otherwise, in the morning again you can see check the schedule, and if any one of you is not using Facebook, then you can call in the office till 7 p.m. to ask for that, to ask for the schedule of the next class. Okay, anyways, that's all for the day. See you in next class, and try to solve assignment 1 questions. If you have any doubt in the assignment 1 questions, then we will discuss the assignment 1 in the tomorrow class, and that will be the last day for the assignment 1. After tomorrow, after Tuesday, we will not discuss the assignment 1. Okay, so if you have any doubt regarding assignment 1, we can discuss that in next class tomorrow on Tuesday, that is 7th June, I guess, sorry, 7th July. Okay, after that we will not discuss the assignment 1 problems. So if you haven't solved that assignment 1, solve it by today. See you guys, thank you. And bring the GATE previous year papers book, the question book, PDF, whatever it is, from next class. Okay.